As we get closer to our dedication ceremony on the 4th of May, there's a great deal of activity with our sculpture project. In our last episode, we showed a local grounds maintenance crew topping the copse in the centre of the roundabout. Today, we are laying the foundations for both the victorious horse and knight on the roundabout and the riderless vanquished horse on the verge opposite. Before this can begin, the usual flow of traffic has to be altered. 2 lanes are normally available to vehicles, but this is being reduced to 1. We don't expect this will cause significant delays to travellers, but it is important for the safety of the workforce. Posts mark where the foundations are to be dug on both the roundabout and the verge. Before this begins, measurements are taken to confirm the dimensions are in accordance with the plan. One vital step is to check if there are any underground cables or pipes that may be hidden beneath the surface about to be opened. To provide a clean edge and ensure loose soil does not break away from the sides of the hole later on, the turf is cut around what will become the sides of the hole. Unfortunately, these flowering daffodils are just where we intend to dig. But the blooms will find a good home and the bulbs will recover next year. With preparations complete, the digging can now begin, and this is the moment when the first turf is cut. Most of the spoil from both holes will be removed from the site, but some is retained. This will cover the concrete foundations after the horse is installed. The sides of the holes are kept vertical and smooth. When they have been dug to the depth detailed in the plans, they are filled with the required grade of crushed stone, which will underlie the foundations. This is tamped down to provide a solid base. Wooden shuttering is installed around the inside edges to control the liquid concrete and ensure it will be level when hard. Concrete is a very heavy material, so the shuttering has to be securely pinned with timber stakes. Each sculpture has a lance, and its lower end is to be fixed within the foundations after each horse is in position. Phil has made boxes which he attaches to the shuttering where the end of each lance will be. This will keep the concrete for the foundations away from this area when it is poured in. This vehicle mixes the concrete to the specified formula and volume, on site and for this job, so there's no waste. A base layer is poured into each hole. When raked level, reinforcing steel mesh is inserted to provide additional strength to the foundations. The top screen is then poured over the mesh, is raked level at the top of the shuttering, tamped down and smoothed over to give a good finish. In a few days, the concrete will be completely solid and able to support our horses. Both foundation areas were fenced to provide security for the site. Children at Turlbrook School created designs for 2 pennants to be attached to the top of each lance. These designs were cut into stainless steel by Grail Engineering, after which they were moved to Grail Engineering in Cinderford. To create the impression of movement in a fabric, each pennant is having 2 slight bends put into it.
All I'm doing there is just setting the gap for the thickness of plate that's going through. So just making sure he's nice and equal. So obviously if he's down more on that end than that end, what happens when you roll him, he'll roll uneven. So you need a nice even pressure. I'm using a 4mm plate, obviously, just to set the thickness of the roller, so when I roll him through, he's nice and even from one end to the other.
He's going one way, then he gets sub out there, and reverses the other way. So he's an S-bend, really. Stop about there where the weld is, and then tail it off the same way on the leading edge.
Right.
That's doable.
Yeah. So that goes that way, and then you go in that way,
and then continue off that same bend right through.
But then you want to miss that and carry on to the end.
Yeah, miss that. There'll be a bit of a flat, and then say if that's going that way, we want that to continue.
The gap between the rollers determines the strength of the bend, so Justin is cautious, adjusting them a little at a time.
If that holds, that should be all right. Yeah.
Yeah. You want to take him out and look?
Whip him out and look. Shall we see how it goes?
All right.
There, yeah. That's nice, giving him a bit of life. So he's out straight.
So you want to come back?
He'll come back again. Avoid
that there.
a critical point.
Yeah.
Yeah. The rest can go all the way back that way. Yeah.
All right.
Yeah, like that. Right.
We've got no pressure on there.
Gonna get you, Colin.
Inch by inch, the pennant passes between the rollers. Gently does it.
Yeah.
Right. There. Right.
Carefully and gradually, it is removed from the rollers.
Well, it's bent.
Waving in the wind. Yeah, that's fine. That's nice there, the tail off.
But if you think about it, a flag is not going to ripple.
They do all sorts, don't they?
Yeah.
A lot of the leading it, don't they?
If you probably slow it down, you probably see flats and ripples and creases in it
it's
anyway.
An organic thing.
Yeah.
That's a hell of a lot better than absolutely flat.
The pennants will be joined to an upper section of each lance, using stainless steel metal brackets, as Justin explains.
Actually, that attaches the flag to the actual pole, and this is how we form it to get it down onto the brake pressing for folding. Right. Well, that's what will be actually attaching to the pole and the flag there. So we run that's a 3D model developed in SolidWorks. Doing now is creating our tool setup and our bend sequence for all the angles to actually develop that shape. So that's the first part of it. Okay.
With the specification in the programme, Justin goes down to the workshop.
Alright, so the plan is here, we're forming a radius, and to do that we're forming it with a multitude of bends. So obviously we've got to check the first angle measurement on the bend, so we know it's going to form that radius correctly. So what I'll do is I'll push them in, check the first bend with the digital protractor, and then hopefully we'll go on from there and produce the radius. Right. Happy with the angle measurements, so what I'll do is carry on from there, check them as I go to make sure it's not increasing or decreasing, okay?
Final check with the computer, and Justin bends the angle.
Right, that looks okay to me.
Now is the moment to gradually bend the radius. Press after press after press, carefully inserting a slight bend until the radius is formed. What you are watching now is our film of the process speeded up 7 times.
Yeah, that's basically how you form a rad on the brake press. Because obviously that's too tight to roll, so unless you had a proper former, The next way around it is step bend it.
No, you're not moving down a tunnel. What you're doing is looking through the inside of one of the lances. Each of the huge lances is made from 2 sections of aluminium tube that have to be joined together. Justin has inserted a sleeve to hold them together and now welds the join and several spots to be sure of a solid connection.
I've just taken all the dirt and any impurities out of it before I weld it. Just making sure the metal's nice and clean. Right, what I'll do is I'll tack him first.
When the lances are completely assembled, they'll be collected and moved to Edwich Yard in Tewkesbury. Thank you for watching. With plenty happening, our next episode will be produced shortly, so please look in again soon.